Hey everybody, welcome back. Apologia 8th grade Physical Science Week 6, Day 3. Textbook pages 90 to 93, notebook pages 75 to 77. Today we're going to discuss the atomic number and the atomic mass number. Dalton predicted that the atoms of one element would have different masses and properties from all other atoms. What makes the atoms of different elements different from each other? Well, it has to do with the discovery of the subatomic particles. With that discovery, scientists were now able to describe the differences between atoms of one element and atoms of other elements, just as Dalton had predicted. It turns out that all the atoms of any given element always have the same number of protons. For example, there is only one proton in every hydrogen atom. No matter what, there will be one proton. In every helium atom, there are two protons. So any atom that has only one proton will end up being a hydrogen atom, and any atom that has two protons will be a helium atom. Since the number of protons in an atom is fundamental in determining what kind of atom it is, the special term we use for that number of protons in an atom is called the atomic number of the atom. So again, the atomic number is the number of protons in an atom. And again, all the atoms of any given element will always have the same number of protons. We can see here that this has one proton. So we know if there's one proton and one electron, we know that's hydrogen. Here we have two protons. We actually have two neutrons and two electrons. So we know that that is helium. So hydrogen has an atomic number of 1 and helium has an atomic number of 2. If you look at an atom, you can count the protons. So for example, we have carbon. 1, 2, 3, 4, 5, 6. 6 red protons. All right. There are 6 protons, which makes that atom a carbon atom, since carbon has an atomic number of 6. In the end, the number of protons in an atom tells you what kind of atom it is. And since atoms are neutral and they must have equal numbers of protons and electrons, it also tells you how many electrons the atom has. So let's go back. We said we had 6 protons. So that means we have to have 6 electrons for this atom. 1, 2, 3, 4, 5, 6. Because the electrons swirl around the outside of an atom, it is the electrons of one atom that affects the electrons of the atoms it comes near. If you think about it then, it's the number of electrons in an atom that will be the most important factor in determining how one atom behaves relative to another. Thus, the number of electrons in an atom determines the vast majority of an atom's properties. And we can know the number of electrons in an atom by the number of protons it has, which is the atomic number. Well, what about the neutrons? How does the number of neutrons in an atom affect the nature of the atom? Well, the short answer to this question is it really doesn't do much. We know that neutrons have a tiny bit more mass than protons, so each neutron will increase the mass of the atom. But because neutrons have no electrical charge, they're neutral, they do not affect how many electrons an atom has. As a result, the number of neutrons in an atom has only a small effect on the properties of that atom. Even though the number of neutrons in an atom affects the properties of the atom only slightly, we still want to keep track of them, and scientists have defined the mass number of an atom to be the sum of the protons and neutrons that exist in the nucleus of an atom. All right, so let's look here. We have a mass number of 12. Where is that coming from? We have 6 red protons, and now we have 6 blue neutrons in the nucleus, or in the center of this carbon atom. 6 plus 6 is the atomic mass number, which gives us 12. This is just a picture kind of describing how important the electrons are, or even more important, the electrons are, especially the outer layer of electrons, or our valence electrons. It's the number, really it's the number of electrons in an atom is the most important factor in determining how an atom behaves relative to another atom. We'll talk about bonding and things like that in the next module. I just wanted to show you. All right, so in review, we have the atomic number and the atomic mass number. So here we have the atom illustrates on the right. For example, helium, we have 2 protons, 2 neutrons. So we have 2 protons, the positive. We have the 2 neutrons in the nucleus. We also have the 2 electrons. The fact that it has 2 protons determines that it also has 2 electrons. It also tells us that it is a helium atom. Since there are 2 neutrons in the nucleus as well, the mass number of the atom is 4. 2 neutrons plus 2 protons. As a result, we call the atom helium-4. So a quick review, the atomic number, the number of protons in an atom. So again, the atomic number is the number of protons. There are 2 protons. It's helium. It has an atomic number of 2. The mass number is the sum of the protons and the neutrons in the nucleus. So we have 2 protons, 2 neutrons. So the mass number is 4. All right, the hydrogen atom here, we have 1 proton and 1 electron. So it has an atomic number of 1. But notice that there are no neutrons in the hydrogen atom. So that gives hydrogen a mass number of 1, because 1 proton and 0 neutrons is 1. So hydrogen 1 is actually the only atom that has no neutrons. That's pretty cool. All right, which brings us to discuss isotopes. There are actually 3 different kinds of hydrogen atoms in nature. Notice that all 3 of the atoms illustrated here in this figure have 1 proton and 1 electron. They have to have 1 proton to make them hydrogen. Despite the fact that they all have the same number of protons and the same number of electrons, they have different numbers of neutrons. And as a result, they all have different mass numbers. The atom with just 1 proton and no neutrons is hydrogen 1, and that is sometimes referred to as protium. So here we have hydrogen 1, protium. The atom with 1 proton and 1 neutron in its nucleus is hydrogen 2, deuterium, 1 neutron, 1 proton. So hydrogen 2, or deuterium. And the atom with 1 proton and 2 neutrons in its nucleus, 1 proton, 2 neutrons, is hydrogen 3, which is also called tritium. Scientists have a name for atoms like this, and they are called isotopes. Isotopes are defined as atoms of an element with the same number of protons, but different numbers of neutrons. And again, to make it an atom of an element, it has to have the same number of protons. Isotopes of an element have the same atomic number but different mass numbers because they have different numbers of neutrons. All isotopes are identified by the name of the element followed by the mass number. Only hydrogen has different common names for its isotopes. Remember, hydrogen 1 was protium, hydrogen 2 was deuterium and hydrogen-3 was tritium. Well, it's the only one that has names for its isotopes. However, hydrogen isn't the only element that has isotopes. The helium-4, I think we have that pictured over here. Hold on. Helium-4, that is pictured here. We have helium-4. Is one of 3 naturally occurring isotopes. The other 2 isotopes are helium-3 and helium-5. Can you figure out how many neutrons each helium isotope has? All right, let's take a look at that. Also, we're going to draw this on notebook page 76. So helium-3 has 2 protons, and then to get that 3, it needs to have 1 neutron. So helium-3 in its nucleus has 2 protons and 1 neutron. Helium-4 has to have 2 protons, but now it has 2 neutrons in its nucleus. So helium-4, 2 protons plus 2 neutrons equals 4. Helium-5, again, we have the 2 protons and the 3 neutrons in its nucleus. That makes it helium-5. Isotopes, atoms of an element with the same number of protons but different numbers of neutrons. Okay. Example 3.1. All atoms that make up the element nitrogen have 7 protons. If a particular nitrogen atom has 8 neutrons, what is its name? How many electrons does it have? All right, let's think about this here. If it has 7 protons, it will have 7 electrons. Let's just put that out there. So at least we know 7 protons, and it has to have 7 electrons. But if it has 8 neutrons, what would its new name be? If you said nitrogen 15, you would be right. So, and with 7 protons plus 8 neutrons, the mass number is 15. So we would call this nitrogen 15. Example 3.2. Which of the following atoms is an isotope of nitrogen 15, and what is its name? Is it A, an atom with 5 protons, 5 electrons, and 10 neutrons? Is it B, an atom with 8 protons, 8 electrons, and 7 neutrons? Is it C, an atom with 8 protons, 8 electrons, and 8 neutrons? Or is it D, an atom with 7 protons, 7 electrons, and 7 neutrons? All right, there's only one possible answer, and it has to be D. Because we know that nitrogen, no matter what, has 7 protons. So the answer is D, an atom with 7 protons, 7 electrons, and 7 neutrons would be an isotope of nitrogen 15. All right, on your own. The element sodium is made up of all atoms with 11 protons. How many protons and electrons and neutrons are in a sodium-23 atom? All right, so we know there are 11 protons in sodium. That means we automatically know that there are 11 electrons. So how do we figure out how many neutrons are in there? Well, we look at our sodium-23 and we subtract the 11 protons from the 23. So all sodium atoms will have 11 protons, which tells us that it also has 11 electrons. With a mass number of 23, we can figure out the number of neutrons. 23 minus 11 is 12. On your own, 3.7. Of the following atoms, 2 are isotopes. Which ones are they? Now let's just review. To be an isotope, you have to have the same number of protons. So An atom with 16 protons, 17 electrons, and 17 neutrons. An atom with 17 protons, 17 electrons, and 16 neutrons. An atom with 16 protons, 16 electrons, and 18 neutrons. Or an atom with 18 protons, 18 electrons, and 17 neutrons. This should be quite easy for us. We know to be an isotope, they have to have the same number of protons. So it has to be A and C. All right, I hope this helps. Good luck.